Hi, it's me, Tim Dodd, the Everyday Astronaut. Welcome to the 2020 Astro Awards. Now, this is a time where we reflect on all the exciting things that happened throughout the year in spaceflight and space discoveries. And this year is extra important and impactful because, frankly, in general, 2020 sucked. For all of us. But thankfully, for those of us who are fans of spaceflight and space discoveries, we actually had a ton of incredible good news, groundbreaking discoveries, and huge feats of engineering and science to get excited about. So without further ado, may I present to you the 2020 Astro Awards. Hello and good evening, everyone, and welcome to the 4th annual Astro Awards. Each year, we pick our favorite space moments and award the winner the much coveted Astro Award. And no, this isn't just a bronze space shuttle that I found on eBay. It's the Astro Awards. It's the Astro Award. Look at it. You know this. Everyone knows that. That's the Astro Award. Now, I swear, someday we'll get legit awards made and hand them out to those involved in these programs. And I know I've said this for the past couple years, but I really want to do these in person next year and actually fly those who are nominated out to celebrate their achievements. Because the Astro Awards is our chance as the general public to lift up, celebrate, and thank those who dedicate their lives to furthering our knowledge and understanding of the world we live on and help us understand our place amongst the vast universe. 2020 was perhaps one of the most exciting years for spaceflight, at least since I've been following it closely. It was an incredible year. Despite the pandemic slowing many programs down for months, the overall number of launches was impressive. Now for the Astro Awards, I took your input, let you guys vote on the most impactful and significant events, and then I jumble and rearrange them because you're wrong. Well, not really, but this isn't really serious business here, and at the end of the day, I get a say in what I think are the most profound and impactful events of the year. Not only do I factor in scientific significance, but also cultural impact that can help people dream and think about space and spaceflight. Now, before we get started, let's take a few moments to reflect and remember some of the great people, missions, and programs that we had to say goodbye to this year, starting with a few important people who made an impact in space history. Those of you who lost loved ones this year, our thoughts and prayers are with you. Their work has helped shape an industry, expanded our horizons as humans, and literally changed our understanding of our place in the universe. Their legacies live on. And although not even close to as tragic as losing a loved one, we did see the end of some missions and hardware, planned or not, that I thought would be worth sending off. Saying goodbye to Dragon 1 as it's now officially been retired and replaced by Dragon 2 for both crew and cargo was easy. We knew that was coming and the upgrade to Dragon 2 is awesome. Same with Mitsubishi Heavy Industries H-2B rocket from Japan that successfully launched 9 times, each time carrying the HTV resupply vehicle to the International Space Station. They'll be replaced by an upgraded HTV-X, which will fly on a new H-3 rocket. But losing the 300-meter dish at Arecibo Observatory in Puerto Rico was devastating. 2020 took so much from so many people, and losing the iconic and powerful main dish was just a nice friendly jab that things can always get just a little worse. Unfortunately, it collapsed on December 1st after it had already lost 2 main cables, one in August and one in November, and it was left in too dangerous of a state for anyone to get near it and risk serious injury. And unfortunately, the remaining cables were just too weak to continue to hold the 900-ton instrument above the dish. Okay, we don't want to sit here and sulk in sadness because that was already most of our lives in 2020. But we actually have a ton of exciting things to talk about from this year. So let's dive right in with our honorable mentions. Now, right off the bat, in kind of an informal way, I wanted to make sure and give some recognition for both Virgin Orbit and Astra, who both had orbital launch attempts this year. Virgin Orbit went for their first orbital launch attempt on May 25th, 2020, of their air-launched Launcher 1 rocket. But they lost an engine almost immediately upon ignition. They quickly identified the issue and have a high degree of confidence their next attempt will work out. So we'll get those pom-poms ready. And Astra had 2 orbital launch attempts this year of a Rocket 3 launch vehicle. The first on September 12th, which was intentionally shut down after about 30 seconds because of guidance issues, and the second on December 15th, which almost made it into orbit. It was only about 500 meters per second short of orbit, which is so darn close. I'm quite confident they'll figure it out. So hopefully next year we can get some Astro Awards out for some fun new small-sat launchers. But meanwhile, we have some fun other honorable mentions. SpaceX and their Falcon 9 rocket took things up a notch this year. Now, because it didn't really do anything new or of any particular importance, it's not on our main list to win an Astro Award, but I just wanted to reflect on how nutty of a year it was. SpaceX launched 26 Falcon 9s in 2020. That's over twice as many Falcon 9s as they launched last year, and they easily broke their 2018 record for the number of flights of 21. And that's just for Falcon 9 flights, not Falcon Heavy or anything to do with Starship. That's impressive. But this year, we also saw 2 boosters fly for their 7th times. That's up compared to the most flown boosters only having flown up to 4 times last year. But we even saw one particular booster, booster B1051, fly 5 times this year alone. Turnaround times between flights decreased dramatically this year too, as SpaceX streamlined Falcon 9 refurbishment. In the second half of 2020, the average turnaround time was about 75 days, compared to 140 days on average in 2019. That's a huge improvement. And not only that, the Falcon 9 celebrated its 100th successful launch this year. An awesome milestone for a rocket that's only been flying for about a decade. But a fun side note, this year SpaceX, I guess, thought it was a cool new trend to make it so rockets were leaning. I mean, we saw 2 boosters come back into port with a pretty extreme lean, and they must have been talking to Starship, or SN9 just wanted to get in on the fun and ended up leaning over in a similar manner inside the high bay, which was a bit of a whoops, but nevertheless kind of crazy. Next year, I'm assuming we'll have to develop some kind of pointy end up-ish, flamey end down-ish report or something to help really assess those situations better, because I was ill-prepared. But we have one other honorable mention that I wanted to highlight. This year, we saw some real, genuine progress towards getting humans back to the moon for the first time in about 50 years. Despite nothing having actually happened yet, I wanted to stop and celebrate some progress. We saw NASA make 2 big milestones for their return to the moon with the Artemis program. The first was in April when NASA awarded 3 contracts for companies to develop lunar landers, known as HLS, or Human Landing Systems, for the Artemis program. The 3 companies to win contracts were Dynetics, National Team led by Blue Origin, and SpaceX with a Starship variant. This is the first time since the 60s that there's been legitimate funds invested in a human lunar lander. In 2021, we'll see a down select to 1 or maybe 2 of those landers to end up getting more funding to make it into the next round of development. But perhaps even more exciting, we have a list of the first humans that NASA has chosen to return to the moon. 18 astronauts were announced for the initial team. Now, there might even be some familiar faces in here for you, including Kate Rubins and Victor Glover, who are currently on the ISS as we speak. The more and more Artemis solidifies, the more excited I get, especially after I did that video comparing the Artemis program to the Apollo program. I used to think the Artemis program was kind of not that great, but after making that video, I am truly excited to live in the Artemis era. And our last honorable mention is the discovery of phosphine on Venus. This is one of those discoveries that was published in 2020 that was maybe too awesome, because there's now some controversy. Scientists published a paper in September showing that they had observed the signatures of phosphine in Venus's atmosphere. Using the Atacama Large Millimeter Submillimeter Array, or ALMA telescope, and the James Clerk Maxwell Telescope, or JCMT, team leader Jane Greaves at Cardiff University found phosphine to be about 7 parts per billion in Venus's atmosphere. The reason that this is such a big deal is we don't really know of a good mechanism to create phosphine other than organic life. But of course, there could be non-living sources that are yet unidentified or undiscovered. Since the paper was published, there was a data error observed, and now the amount of phosphine being reported is down to just 1 part per billion. But like good scientists, we're seeing the scientific method at work as others try and replicate the findings. If it's indeed confirmed, discovering phosphine in Venus's atmosphere would be a huge deal and would definitely be worthy of an Astro Award if that's the case. So let the scientists science, and maybe we'll see more and more exciting surprises from Venus in the upcoming years. Okay, now it's time to start giving out some Astro Awards, starting with number 10. Our first Astro Award of the year goes to something that just happened. On December 19th, the International Space Station gained a new doorway to space, or more specifically, an airlock. Anorak sent their Bishop airlock up on SpaceX's Falcon 9 and Dragon 2 vehicle for CRS-21 on December 6, 2020. It was put inside that large unpressurized trunk section of the Dragon capsule, and then once it was docked with the ISS, the airlock was taken out of the trunk by Canadarm2. Yeah, Canadarm. There's no other A. Canadarm. The reason this is exciting is twofold. First, this is the first ever commercial airlock to be installed, which can be utilized by both commercial and government customers. Second, it's big and allows for very large items to be moved in and out of the ISS. The airlock is kind of backwards from a traditional airlock, or it's hard to recognize how it works. While it's docked, it looks pretty normal, but there isn't a second hatch on the outside or anything. It's just basically a cup attached to the ISS. When it's docked and the hatch to the ISS is open, it basically just looks like a decent sized room. Then astronauts can load it up with CubeSats to be deployed, or science experiments, or even small sats. Whatever they want to expose to the environments of space, they can put it up right in there and then seal up the hatch. Now the magic begins. The airlock is depressurized, and then it's kind of undocked or unberthed and picked back up by the Canadarm. The Canadarm then basically can just point or aim the airlock in any direction and either deploy CubeSats or discard trash or simply expose experiments to space. When done, they just reverse it. It's actually a really simple and creative solution that, believe it or not, will have an even bigger impact on the ISS than I think a lot of people realize. The ISS's experiment racks and the Japanese Kibo module are backed up and unable to support more experiments. Okay, maybe I'm just a little biased because I've actually been inside the actual flight hardware, which is pretty cool to think about. So congrats to the teams at NanoRacks for thinking outside the station and helping to expand the abilities of the ISS. This year, Northrop Grumman did something that had never really been done before, I don't think. And although it might not seem like a big deal, it's actually quite profound. Northrop Grumman launched a satellite to go up and dock with a dying satellite in geostationary orbit to extend its life. Now, first, let me quickly explain why satellites typically have a lifespan. They have tiny onboard maneuvering thrusters that usually run on a monoprop or some kind of highly storable fuel that have to do these little tiny maneuvers to keep it perfectly in an exact and precise orbit, otherwise known as station keeping. And of course, propellant is a limited supply, so once the propellant gets nearly empty, the satellites typically either deorbit if they're in LEO, Or if they're in a high orbit, they throw themselves out to a graveyard orbit where they won't affect any active satellites. So you've got this, say, $200 million satellite, and it's just hanging out there and it's working perfectly fine, but it's just low on fuel. And unfortunately, your only option is to get rid of it so it doesn't become space debris, despite otherwise being fully functional. Welcome the Mission Extension Vehicle, or MEV. The first MEV launched in October 2019 on a Proton rocket, and it hitched a ride along with Eutelsat 5 West B, which was already heading out to geostationary orbit. Using highly efficient ion electric propulsion, the MEV matched the orbit of Intelsat IS-901 in its graveyard orbit. Then it did something pretty genius. Since satellites aren't usually built with docking ports, it grabbed onto the satellite's engine bell in the combustion chamber, which is of course capable of applying forces to the spacecraft. So now Intelsat IS-901 can have about 5 years added to its lifespan, which could be hundreds of millions of dollars in revenue for a satellite. So once that 5-year lifespan is over, the MEV will put it right back into the graveyard orbit, and then the MEV is going to go out to its next customer. And it can do this for a total of about 15 years. But what's fun for some of us spaceflight fans is some of the imagery brought back from this first mission. This is the first time a satellite has ever docked with another satellite in geostationary orbit, and for some reason, it's strangely beautiful to me. It almost has that same morbid curiosity sense, like seeing a shipwreck or an abandoned building or something to me. I'm not sure I can explain it, but I sure do love it. I can't wait to see more robotic missions like this, and more life extension missions too. I honestly think it's super cool, and I think it bodes well for our future in space. So congratulations to the teams originally from Vivisat, at the time owned by US Space and ATK, then later merged with Orbital, and then finally merged with Northrop Grumman. To all of you, thanks for taking a good idea and making it a reality. It was the summer of Mars. This year we saw 3 Mars-bound missions successfully take off and are on their way to Mars as we speak. That's right, we're about to have 3 awesome new missions capable of helping us learn even more about Mars in 2021. Now you might be sitting there going, wait, 3 Mars missions? Why is this number 8? This can't be right? Those are huge missions. Well, remember how I get the final say in the order of these? Yeah, well, here's why. I'm sorry, but this one I just had to override. You guys wanted it to be number 3, but to me, this is literally just the start of the journey, and the missions themselves haven't even really started yet. This feels a little bit to me like celebrating that you successfully drove your car to a marathon that you're about to run. The hardest parts are yet to come. But regardless, I wanted to make sure we give recognition to those awesome launch providers who did have perfect mission success in launching these missions and, get you hyped up for 2021 when we get to see all these missions arrive at the Red Planet. In order of launch date, on July 19th, 2020, the United Arab Emirates launched their first mission to Mars, and it's fittingly called the Emirate Mars mission. It launched on top of a Mitsubishi Heavy Industries H-2A rocket from Tanegashima LP-1 in Japan. And dang it, I honestly think that rocket looks so cool. It's composing of a single Mars orbiter known as Al-Amal, or Hope. The 1,350 kilogram probe is scheduled to arrive at Mars on February 9th, 2021, where it'll need to do an orbital insertion burn and then begin its mission soon after. Then on July 23rd, 2020, we saw China launch the Tianwen-1 spacecraft on their largest rocket, the Long March 5 from Wenchang LC-101 on the Chinese island of Henan. And this spacecraft is an absolute beast. China went all out on this launch window with a trio of vehicles, an orbiter, a lander, and a rover. In total, these 3 spacecraft weigh about 5 tons. If successful, this will not only be China's first orbiter to succeed, but it could also be their first lander and their first rover. It's scheduled to arrive at Mars between February 11th and 24th, and will first get into an orbit and eventually circularize itself. Currently, the lander and rover are scheduled to touch down on April 23rd, 2021 at the Utopia Planitia. And lastly, on July 30th, 2020, the United States launched Mars 2020 on top of ULA's Atlas V in the 541 configuration from Slick 41 at Cape Canaveral Space Force Station. Mars 2020 features a follow-up of the Curiosity rover named Perseverance. But much like Tianwen-1, Perseverance isn't traveling alone. It's got tucked under its belly a first, a small helicopter called Ingenuity. Perseverance is based on Curiosity and is even made out of some spare parts. But it's taking everything Curiosity had up a notch, or 2, or 10, including way better cameras, microphones, upgraded wheels, an instrument called MOXIE, which is an in-situ resource utilization that's going to make oxygen on the surface of Mars, and an awesome core sampling and caching system. If you want to know more about Perseverance and how it compares to Curiosity, we've got an awesome video breaking it all down for you. There's honestly way too much cool technology to get into right now. It's scheduled to arrive on Mars on February 18th, 2021, and will utilize that exact same daring re-entry system as Curiosity, featuring the awesome Sky Crane. I cannot wait to tune into that. So for now, we can celebrate 3 perfectly successful launches, and that's definitely something to be excited about. But 2021 will be the real treat when the spacecraft arrive at Mars and begin their actual missions. So congrats to the teams at the China National Space Administration, the teams at UAE's Mohammed bin Rashid Space Center and LASP, MBRSC, UC Berkeley ACU, all for a great start so far, but also Mitsubishi Heavy Launches for a flawless launch. And lastly, congrats NASA, JPL, and United Launch Alliance for a successful start to an exciting mission. We all cannot wait to see what 2021 will bring us. Not only was 2020 the year of Mars missions, it was also a year packed full of sample returns. And this one in particular, quite literally, is packed full of sample returns. And I wanted to recognize it because in a way it did too good of a job collecting samples, but it's here at number 7 because it too still isn't quite done with its mission. I'm of course talking about the best backronym ever, OSIRIS-REx, or the Origins Spectral Interpretation Resource Identification Security Regolith Explorer. This was a probe launched way back in September 2016 on an Atlas V 411 from Slick 41, Cape Canaveral Space Force Station. It rendezvoused with asteroid Bennu on December 3rd, 2018, and since then, it had been mapping and collecting data about Bennu before it began its touchdown and sample sequences. It even did a few test runs where it would really get close to touching Bennu, but then would fly away. But finally, on October 20th, 2020, the mosquito-like OSIRIS-REx went in for its bite. Using a Roomba on a stick, basically, the probe booped the surface of Bennu by shooting nitrogen through its TAGSAM collection instrument, which then traps samples. Now the good news is it caught a lot of rocks and samples. Approximately 400 grams, which is way more than the 60 grams required to be a minimum successful collection. The bad news, it caught a lot of rocks and samples. It collected so much asteroid that the door meant to close the collector couldn't close completely because it was too full. But luckily, not too much leaked out and the entire collector was stowed properly, which means it's officially time to head back. The spacecraft will begin departure in March 2021 and won't arrive back to Earth until September 2023. So we've got some waiting to do. Congrats to the teams at NASA, Lockheed Martin, and University of Arizona for making a spacecraft with a huge appetite and successfully capturing as much of that delicious asteroid as possible. Oh, Rocket Lab, Rocket Lab, Rocket Lab. Another big year for a small company. This year, Rocket Lab accomplished 2 major milestones. First off, they successfully launched their first satellite bus called Photon. Now, I don't think I quite realized how big of a deal this was until I spoke with their CEO, Peter Beck, about it.
I guess one of the things that always frustrated me is that I have a launch vehicle, and you take the kick stage. It has, GPS, comms, IMUs, reaction control systems. It is a satellite in its own right. And it would always frustrate me that literally 6 inches away from my satellite is another satellite with sometimes exactly the same equipment on board. And you know, I deliver my customer satellite, and then my satellite's in orbit. We play with it for a while, and then we turn it off. It just seems incredibly wasteful.
Seeing that Photon launched successfully and is now in service means companies can just attach their science to the spacecraft and not need to develop their own propulsions, comms, electric, guidance, or thermal systems. They can just plug right into the Photon and let Rocket Lab take care of the rest. But that's not all that Rocket Lab did this year. Perhaps the coolest thing they did was successfully recover an Electron booster. Yeah, I'm sure you guys already knew all about this, but you know, it's just amazing. Their plans to survive re-entry and simply parachute down appears to have worked out fantastically. For now, Rocket Lab hasn't tried part 2 of recovery, which is swooping it out of the air with a helicopter before it splashes down, which is something they've practiced. But even so, they still successfully recovered their booster after splashdown, and they brought it back in one piece to check it out later. This makes Rocket Lab only about the 4th orbital class rocket booster to be successfully recovered after launch. We of course have the Falcon 9 and Falcon Heavy, which is one family. Then there's the Space Shuttle solid rocket boosters and the Orbiter. And then there's the Ariane 5 boosters, which were initially recovered for data purposes on early launches. But now we have the Electron. That's a pretty exclusive list of rockets there, my friends. Rocket Lab is making fantastic progress on something that's extremely hard to do. And to top it off, they're already going to be reusing some of the parts from that mission on upcoming missions. So congrats, Rocket Lab, to your 7 launches this year. Congrats on recovering extremely quickly from a failed mission. But cheers to the success of Photon and your efforts for booster recovery. We can't wait to see you catch a booster in 2021. Starship is number 5, Tim? Have you lost your mind?
Okay, here we go. Relight! Yes! No way! No way!
Well, judging by my reaction to seeing serial number 8 fly and attempt to land, yeah, I probably have. Starship has been making steamroller progress, and it's extremely ambitious, fast-paced, and very public. It's so public that those of us who are people interested in seeing Starship, otherwise known as, no, we better not say that. Those of us that follow Starship progress closely tend to get very, very excited about every little milestone. But we saw some big milestones this year. We saw 3 different Starship prototype vehicles leave their launch pad and fly. Serial number 5 and serial number 6 flew only about a month apart, proving that SpaceX was speeding up their manufacturing and that serial number 5's flawless hop wasn't a fluke. And then came the big one, SN8. Now I'm sure you're all fully aware of SN8's flight by now, but here's why this deserves a spot on our list. SN8 demonstrated the first time multiple full-flow staged combustion cycle Raptor engines powered the same vehicle. It also had the longest known runtime of a Raptor engine, serial number 42, the first time a rocket has fallen in a controlled manner belly first from a high altitude, and perfectly controlled for that matter, and it was the first time that belly flop to tail down maneuver was successfully demonstrated. If it wasn't for the methane header tank losing pressure and starving an engine during the final landing, it would have likely been a perfectly successful test, which is huge considering there wasn't that much confidence it'd even make it to its apogee of 12.5 kilometers. And this portion is really about the nuttiest part of the Starship program. That landing sequence would make even the most hardened and daring test pilots weak at the knees. But this isn't hardly the beginning of the hard steps for Starship. Once they nail this landing sequence, we'll likely see higher and higher and faster landing attempts to see how the vehicle handles higher temperatures as it gets ready for orbital re-entry, which is the real killer. Because re-entering from orbit in one piece and then doing that landing maneuver will be a huge deal. And Starship's dream of being rapidly and fully reusable hinges on it. So that's why SpaceX's Starship didn't get higher up on this year's list. Because yes, it was arguably the coolest, the most exciting and spectacular thing that happened this year. Trust me, I was there and I'm probably Starship's biggest fan. But as far as long-term impact and importance go, it's relatively low on the list, and it's just a small step in the grand scheme of Starship. Starship made some incredible leaps and bounds in progress this year, and the manufacturing rate is downright ridiculous, producing more Starships than they can even fly already. And we'll be here, or hopefully actually there in person again, to cheer on each and every one of them when they do, or at least the big milestones, because I gotta see more of those babies fly, and I wanna bring it to you guys too. So huge congrats to SpaceX for taking big risks, doing ridiculous things with stainless steel, and for bringing us all along for the ride, even when it doesn't quite go as planned. I'm sure you all heard about this one. How could you not? But it might be confusing why finding water on the moon is such a big deal, because haven't we already known that for quite a while, that there's water ice in the shadowy regions of the moon? Well, that's why NASA's Stratospheric Observatory for Infrared Astronomy, or SOFIA's, discovery is such a big deal. It detected water molecules distributed across the lunar surface, and not just in the shadowy regions. It aimed at the Clavius crater, one of the largest craters visible from Earth, and it actually found a decent amount of water, like a soda can of water every cubic meter. Although that's about 100 times less water than the Sahara Desert, it still is a massive discovery. SOFIA is unique because it's a large 2.7 meter wide flying telescope. It's actually stuck inside of a Boeing 747, which is about the coolest idea ever. This allows it to fly about 14 kilometers in altitude, which gets it above 99% of the Earth's water vapor, which helps it get a clean view of the infrared universe. It used its Faint Object Infrared Camera, or FORCAST. Wow, okay, I'm sorry, but that one is the worst backronym. You can't just randomly capitalize letters until it spells something. But FORCAST was able to pick up very specific wavelengths that are unique to water molecules. Other observations have observed that there may be the presence of water on the moon, and likely even in the sunlit areas, but there really had never been a direct observation of how much, and if it was actually water molecules and not just OH or some other hydration. But here's the most perplexing part. Without a discernible atmosphere, water on the sunlit surface should easily boil off and be lost to space. But something seems to be generating the water or trapping it. Now, there's a few ideas, but some people are thinking it could be micrometeorites raining down little bits of ice, which are then deposited on impact, or maybe there's something happening with solar wind, delivering hydrogen to the surface and creating a chemical reaction with oxygen-bearing minerals. But what I really like about this discovery is this is the first time that SOFIA was ever even pointed at the moon and not in deep space. It was really meant to just kind of be a test to see if SOFIA could be used to try and observe water in sunlit areas on the moon. So to immediately stumble upon good data is awesome. All in all, this is great news for humans returning to the moon and exploring. If there's water that's not only accessible in the shadows, but also throughout the moon's surface, it's promising for creating fuel, breathable oxygen, and clean drinking water. So congrats to the teams with NASA's SOFIA telescope, specifically Casey Hannibal, who published her findings from her thesis work at University of Hawaii at Manoa. Super cool. Last year, we celebrated Hayabusa 2 collecting samples at asteroid Ryugu, and this year, we can already celebrate its successful return back to Earth. For a quick refresher though, Hayabusa 2 was JAXA's action-packed asteroid mission to Ryugu. It launched on an H-2A rocket from the Tanegashima Space Center in Japan on December 3rd, 2014. A year later, it did an Earth flyby that flung it out towards the Ryugu asteroid, which it didn't intercept until 2018, 3.5 years after its launch. Hayabusa 2 built on the success and failures of Hayabusa 1, which landed on asteroid Itokawa in November 2005. But this time around, JAXA had packed this spacecraft with loads of other instruments for remote sensing, sampling, and even some mini asteroid rovers. This is the Swiss Army knife of asteroid spacecraft. In 2019, Hayabusa 2 wound up collecting 2 samples, one directly from the surface, and the other after it had shot the asteroid with a projectile, at which point it went up and grabbed samples that were floating away. But maybe one of the coolest things about the subsurface sample is they even deployed a separate camera system to observe the impact while the spacecraft hid on the other side of the asteroid for safety. So they deployed the satellite deployed a separate satellite and a floating gun to shoot the asteroid and then take pictures of it and then tell the main spacecraft it's okay to fly back. I don't know. I just think that's super cool. Like I said, it's the Swiss Army knife of spacecraft. Once the samples were collected, they were placed safely inside the sample return capsule and sealed up in separate compartments, one for the surface sample and the other for the subsurface samples. Then Hayabusa headed home using its onboard ion thrusters. On December 5th, 2020, Hayabusa released that sample return capsule at its closest approach and shot it towards the Earth's atmosphere while it was traveling at a whopping 12 kilometers per second. The sample return capsule safely re-entered, popped its parachute, dropped its heat shield, and then began transmitting a beacon signal. It safely landed in the Woomera test range in Australia, right on target. Absolutely incredible. In total, they collected 5.4 grams of material, which is far beyond their target of 0.1 gram. In other words, they absolutely knocked it out of the park. Studying these samples can help scientists understand our early solar system better because asteroids are relatively untouched compared to active planets. They're just kind of floating time capsules and can help us understand a whole lot about the formation of our solar system. And what's also super cool is that Hayabusa 2 isn't even done yet because the spacecraft just did a flyby of Earth. It's still out there and can continue to do science. It actually has already begun its official mission extension, where it will visit an L-type asteroid. Then in 2031, it'll fly by a fast-rotating microasteroid that rotates once every 10 minutes. So this do-it-all spacecraft has already knocked its mission out of the park and is still out there continuing to do even more science. How awesome is that? Huge congrats to the teams involved in making Hayabusa 2 an absolute home run mission. Like I said, sample return missions are all the rage this year, and China had to get in the mix. And boy, did they pull off a fantastic sample return mission. One of the reasons I think this mission is incredible and deserves to be this high up on the list is because CNSA basically did an autonomous Apollo mission. On November 23rd, 2020, Chang'e 5 took off on top of a Long March 5 from the Wenchang launch site, LC-101. And we mentioned this before, but Wenchang is on an island, which means that the expended boosters are splashed down in the Pacific Ocean and not anywhere near populated areas. Thankfully. The launch went perfectly smooth and even featured my new favorite camera view of a launch, Trench Cam. We found this feed and we just had to have it in our live coverage of the launch. It's just too cool. The Long March 5 put the lander, ascender, orbiter, and returner on its translunar injection, where it coasted up to the moon. Think of these things as the same as the lunar lander, ascent stage, command module, and service module from Apollo. Only these Chang'e 5 modules were pre-assembled, unlike the Apollo program, which needed the command module with the astronauts inside of it to ride on top of the rocket in case of the unlikely event of an abort. Now remember, that ended up requiring that the command module needed to turn around and dock with the lunar lander on the way to the moon. Okay, so back to Chang'e 5. It arrived at the moon on November 28th when it did a 17-minute long braking maneuver to get into orbit. Then on November 30th, the lander and ascender separated from the lunar orbiter. Then on December 1st, the lander successfully touched down on the moon near Mons Rumker in the Oceanus Procellarum. Once there, the ascent stage reached down and scooped up some lunar samples. It also had a coring drill to acquire samples from up to 2 meters in depth. Once all the samples were gathered in the ascent stage, it then sealed them up and took off. Then it did something new, something that had never been done before. The ascent stage autonomously docked with that lunar orbiter while in lunar orbit. Then the ascent stage transferred its sample collection to the orbiter, where it then performed its trans-Earth injection and headed back to Earth on December 13th. 3 days later, on December 16th, the 300-kilogram return capsule re-entered and landed safely in Inner Mongolia. The results of this flawless mission was about 2 kilograms of pristine moon samples. These are the first samples since 1976. That's crazy. And who knows what we'll discover with these particular samples. But doing all of this autonomously is a great sign of things to come. China is really speeding up their exploration and working quickly on expanding knowledge of the moon. I'm sure there's a lot of people out there that are very upset that China is number 2, but you guys know me, I'm Team Space, and I want to celebrate anyone who is advancing humanity's knowledge of our universe. And China is really making huge advancements quickly. I hope that this serves as a friendly nudge for everyone to keep exploring and pushing the boundaries. My friends, a new crewed spacecraft has finally entered service. Finally! Yeah, we did it! I mean, SpaceX and NASA did it. This obviously had to win this year's Astro Award. I mean, come on, how could it not? The world's most beautiful and advanced spaceship is officially in business. SpaceX's Crew Dragon. We saw a ton of exciting Crew Dragon milestones this year, so I wanted to celebrate all of them. At the very beginning of the year, on January 19th, we saw SpaceX launch a Falcon 9 with a dummy second stage. On top of it all perched a Crew Dragon, waiting to leap off of the rocket at the exact moment it'd be the toughest to do so. Then the Crew Dragon aborted from the booster, simulating as if there was a problem on ascent right around maximum aerodynamic pressure, or max Q. The Dragon capsule pulled itself cleanly away from the booster, which soon after blew up big time, being torn apart from aerodynamic forces. The Dragon capsule reoriented itself and completed a safe parachute descent and splashed down exactly as planned. It all went flawlessly. This was the last major milestone before people could step on board and fly the Dragon. So finally, the day had come. Almost exactly 6 years to the day after SpaceX first revealed their Crew Dragon capsule, astronauts Bob Behnken and Doug Hurley boarded the Crew Dragon for flight. And then it happened. Taking off from the exact same launch pad where the last space shuttle mission had flown some 9 years before, Launch Complex 39A. And that was the moment human spaceflight got its first taste of a 21st century spacecraft. The flight went perfectly, getting Bob and Doug to the station about 24 hours after liftoff. The only real hiccup was Doug bopping his head on the ISS's hatch on entry. Other than that, the whole thing was super smooth. After a 2-month stay on station, the Crew Dragon capsule undocked and began its re-entry process. And again, everything went perfect. Right up until splashdown, when a few local boaters decided they needed to be the first to inspect the spacecraft instead of SpaceX. Other than that, the whole mission was textbook, and after a review of all the systems, the green light was given for the first operational crew mission, known as Crew 1. This would be the first time the Dragon flew with its full crew of 4, and also would end up expanding the station to a crew of 7. Crew 1 followed in Bob and Doug's footsteps, quite literally, going up the tower at LC-39A and across the crew access arm on November 15th. The Dragon was loaded up with Michael Hopkins, Victor Glover, Soichi Noguchi, and Shannon Walker. And just like DM2, Crew 1's launch was perfect, getting the crew to station in about 27 hours, where they remain there right now and will be there until about May 2021. I know you all probably know about Crew Dragon and why it's important, but let me just reiterate why this is a big deal. NASA took a risk. NASA decided instead of designing, building, and operating a spacecraft and a rocket, they could just look to commercial partners to do that, and then NASA could just become a customer. The partners who won contracts, Boeing and SpaceX, leaned on NASA's expertise to design and build the vehicles, but they were free to design them however they seemed fit. And this was a big change for NASA, and it paid off. SpaceX delivered an incredible vehicle at a fraction of the cost of what NASA could have built, done it in a fairly timely manner, and not only that, Just look at it. It's actually an attractive 21st century spacecraft. And that's something to celebrate. For now, seats are around 55 million each, which, yes, that's insane. But it's cheaper than the Soyuz spacecraft and cheaper than what Boeing will charge with their Starliner at around 90 million per seat. But this is just the beginning. SpaceX now knows how to build and design a crew-rated vehicle. They've learned so many valuable lessons that they can apply to future vehicles like Starship. And this makes me much, much more excited and confident in the future, knowing they have all of this expertise. Just think, it was only about 12 years ago that SpaceX first got into orbit. Now they're flying reused rockets almost exclusively. They're working on a freaking rocket to take people to Mars, and they actually have experience flying people, so the pieces are really coming together. Human spaceflight is frankly a miracle of modern science. We're pushing the boundaries of what's physically possible. So to see a company do it better, cheaper, faster, and sexier, it's just simply worthy of applause. This is the 21st century, my friends. It is here. As a kid who grew up with a space shuttle poster on my wall, I know that there's kids out there who are seeing this vehicle and dreaming about spaceflight. They're dreaming of putting on that SpaceX spacesuit and climbing inside a properly futuristic looking spacecraft. There's a new generation of astronauts who won't need to use a pokey stick to hit buttons in a crammed module. Spaceflight is changing, and in my opinion, SpaceX is leading the way. So congrats SpaceX for continuing to not only push the boundaries, but also speed up your progress while doing so. The acceleration of advancing human spaceflight is vital, and it's truly inspirational to watch you all push to make it happen. So cheers to you for this Astro Award. Oh man, 2020 was a crazy year for so many reasons. It's been hard for all of us. I mean, each and every one of us has had to make some big sacrifices and do things that we're not comfortable with and make new weird norms, put our dreams, vacations, and goals on hold, and just live in a weird time. And thankfully, we have spaceflight and space exploration. It's something to be united by, something to wake up and get excited about, something to watch change and grow and make progress. It's just simply inspirational and helps me remember that we live in an exciting time. This all sort of feels like the 60s and the Apollo era. The United States was dealing with horrible tragedies and awful times. You know, we had the Vietnam War, which was dividing the country. There were civil rights movements and civil unrest. There were tragic assassinations of really important and influential people. Yet during that same time frame, the Apollo program was a beacon of light, unity, and hope in an otherwise sad reality. And now, looking back, some of humankind's greatest achievements ever happened during those dark times. People in the future are going to look back at this time and see a world that was riddled with problems. See nations torn apart by politics, see people that were sick, dying, and just lonely and growing poor from the global pandemic. And this time it's average people building rockets that will take humans to Mars in a field in Texas. It's the everyday people stepping away from work to tune into an exciting rocket launch. It's humans bonding over our exploration of the solar system. It's humanity coming together to explore. And that, my friends, is what the Astro Awards are all about. And this is my chance to thank not only those of you in the industry, but also those of you at home right now listening to me rant for way too long. You all are making a huge difference. This has been another crazy year for this little YouTube channel. We got another chance to interview Elon Musk and even had Jim Bridenstine join, which is about the coolest thing ever. We got a new studio space, as you can tell. I was able to catch serial number 8 and cover that, which was incredible. And you guys have been so encouraging, and honestly, all of our combined enthusiasm is contagious, and it matters. I wanted to say thank you to my supporters, those of you who are YouTube members and super chatters, and of course, my beloved Patreon supporters. There's so many of you who care enough to help go over my scripts and make sure I'm not making stupid mistakes or question my numbers and my methodology. You all are incredible, and I'm so thankful. I also wanted to thank our website crew who has been putting in tons of hard work to make our website amazing and chocked full of incredible information. In fact, we just released a new version of our website, and you have to check it out for any upcoming launch or past launch. We'll have a ton of new info and lots of awesome tools for you too. And there's even more coming. That's at everydayastronaut.com. And this year I finally hired an editor and helper, Andrew Taylor, who has been a huge help. And it helps me continue to make videos in a timely manner and also increase their quality even when they're an hour long. Sorry, not sorry. I also need to thank Allie Comstock for her amazing graphic design work that you see in our merch, and you also see it all over a lot of our videos. She's got the best eye and helps make everything we do look really good. And a big thanks to Andrew Doyle and the crew down at Overcast Merch in Long Beach, California for kicking so much butt and working overtime to help make our merch awesome and get to people as quickly as possible. You guys are amazing. And one more thanks to my friends Ryan Chalinsky and Mary Liz Bender at Cosmic Perspective, as well as Rachel and Jean at S Padre for helping so much down in Boca Chica and together capturing some epic footage of Starship. And like I said, 2020 wasn't a very good year for large indoor social gatherings, so maybe 2021 will be the first year of in-person awards. We'll fundraise so we can actually fly a small team out so they can actually collect their award and can accept them in person. And we can actually treat them like the rock stars that they are. The plan would likely be to even sell tickets to the public so you guys can join and help make it a giant gathering of awesome people in one place. So more on that next year. Thank you all so much again. You are honestly the best, and I cannot believe this is my job to go from this little weird everyday astronaut project and it's now just my absolute dream job. So seriously, thank you. And if you want to help me continue to do what I do, please consider becoming a Patreon supporter where you can gain access to exclusive live streams, get your feedback and input on scripts, and join our exclusive Discord channel by going to patreon.com/everydayastronaut. Thank you. While you're online, check out our brand new web store with the coolest merch ever, I feel like. Come on, it's awesome. Lots of new things in the store for you guys, including new, bigger, and better moon lamps, drinkware, hoodies, keychains, lots of awesome stuff. So head on over to everydayastronaut.com/shop. Thanks everybody, that's gonna do it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people.